So far, we are familiar with many physical terms like displacement, velocity, acceleration, right? So, and also in our previous lecture, we derived Newton's equations of motion using by graphical method, right? Now, today we will derive Newton's equations of motion with help of integration method, right? Calculus method, right? So, when we are talking about Newton's equations of motion, you always remember that these Newton's equations of motions are valid for uniformly accelerated motion, right? So if the acceleration is constant, then we can apply Newton's equations of motion, right? And one more point, definitely one question will rise in your mind, that if the acceleration is non-uniform, so then how to find out? That also I'm going to tell you that we will use same thing, integration method or derivation. So all this calculus method we will use in order to find non-uniformly accelerated motion. Anyway, let us focus uniformly accelerated motion, right? And we will derive all the equations of motion with help of integration method, right? Now consider, as it is given here, you need to write, if you are exactly explaining, if the question comes derive Newton's equations or equation of motion, maybe first equation, maybe second equation, or any equation, you need to write the initial terms. Consider this particle is moving with initial velocity u and accelerating on a straight line, accelerating uniformly with constant acceleration on a straight line, and consider the velocity becomes v after t second, right? So then we have to derive certain things, right? And if you remember, if the object is accelerating uniformly, then we can find out acceleration is dv upon dt, right? So then in the next step, can I write dv which is equal to a dt, acceleration into dt? Now if I take you to this equation, now see, the motion starts with initial velocity u, and after t second the velocity is becoming v. So the initial time was 0 and the final time, it is not final, for our calculation we are taking time t, right? So then if I integrate, so you can see here, so the acceleration is dv upon dt, so it is instantaneous. Dv means instantaneous velocity with time, since it is uniformly accelerated. So then in the next step we can write dv which is equal to a dt. Then if we integrate both the side, look here, now the velocity, integration of velocity, the velocity starts from u and goes up to v, right? So the velocity starts, the initial velocity is u and final velocity is v. At the same time, the initial time is 0 and final time we consider t. Now if we integrate both the sides starting from u to v and time 0 to t, so then you know that the integration of dv is v and the initial value is u and final value is v. And same way, since a is constant, because you know that it is constant acceleration, uniformly accelerated, so a we take outside as a common factor, then we integrate t, then the integration of dt is t. So then after substituting this value, upper limit and lower limit, we find v minus u which is equal to a into t minus 0, right? So then finally we find v which is equal to u plus at, right? So this is Newton's first equation of motion, right? If you get the question in the examination, you need to mention all the things with graph and diagram and the derivation, right? So if it is clear, if you want anything, so please write in the comment box. Otherwise, let us move to Newton's second equation of motion, right?